So this is the first problem of today's division 2. And in this problem, we're given that chef embarks on a journey starting from a town named S, containing a string of 8 characters, 8 English characters. Now his objective is to reach the destination known as Codetown. So if chef is currently in town T1, then with each move, chef can transition to another town named T2, provided that either T2 is derived from T1 by replacing a consonant with another consonant, or T2 is derived from T1 by replacing a vowel with another vowel. So we need to find whether it's possible for chef to start from like whatever town S he is at, and from there whether or not he can reach Kot town. So this is a very simple problem. See, out of these, there are, this is a vowel, this is a vowel, this is a vowel, and these are the only vowels, right? And the other are consonants. So we can just check that the string S, which like we get in input, it should also have consonants at these places, and at the remaining places, it should be vowel. So hopefully this is clear. You just need to check this. Is anyone having any doubt in this? I just like write a quick yes, no in the chat. I don't think anyone is having any doubt in this. So, okay, so let me show you the implementation. So this is the implementation. I have used, so in this, I have first taken, like for all the test cases, I'm marking, these are the vowels, right? Like you can check them directly here also, but what I've done, I have marked them in a map. Then after this, for each string, I have this flag F, and I'm just checking that if vowel, this is the map, right? If for this character it is 1, it means it should be a vowel, otherwise it is not a vowel. So for the second place, fourth place, and sixth place, I should have vowel, and all the others should be consonants. If the and result of all of these is 1, that is true, the string that I have, I can somehow convert it to code town, otherwise I cannot. So the answer is yes if the flag is 1, otherwise the answer is no. Is it clear? So let's go to the next problem. So in this, we are given a string S of length n and a non-empty string Y is considered beautiful if it satisfies both the given condition. That is, f of cx denotes the frequency of character c in string x, and for every character c present in string y, frequency of character, like frequency of the C character in Y should be less than or equal to frequency of the C character in S. Now we have to find the lexicographically smallest among all possible strings obtained by rearranging the characters of Y. And like string Y is lexicographically smallest among all possible strings obtained by rearranging the characters of I, and we have to find the unique numbers, unique beautiful strings, and we need to print it modulo 10 to the power 9 plus 7. So this is also a very simple problem. Like the only observation is, let's say we have something like, so A in this appears 2 times, B in this appears 2 times, and C in this appears 2 times. So in our final string, anything other than these characters, first of all, cannot be a part of Y. Why? Because if let's say I decided my string Y is going to have D, so f of D, that is the count or the occurrences of D in string Y, is more than f of D of S, right? So that's why I cannot have, other than these characters, there cannot be any other character in my string Y. And now it's completely up to me. I can either take this character once, either I can take it 0 time, 1 time, or 2 time. Why? Because I just need to make sure that f of a of y is less than or equals to f of a of s, right? So only this condition needs to be valid if I'm taking a. So I can take it either 0, 1, or 2 times. Similarly here, and similarly here. So let's say I chose, like, I'm going to take a 2 times, b 1 time, and c 0 times. So I'll get something like a, b. But why is this thing? How to like, do I need to rearrange these? No. Like, there is only, after once I have chosen these characters, there is only one way or one string y which can be formed. That is the lexicographically smallest. I have to sort these characters in increasing order or in non-decreasing order. Why? Because it's given that string y is lexicographically smallest possible. So what is the answer in this? I have three options here. For this character, I have three options here. I have three options here. So just multiply these. And at the end, you need to subtract 1 from your result. That is multiplication result. Why -1? Because you can note, like you can see that there is also one option in which I have selected 0 characters from A, 0 characters from B, and 0 characters from C. So that will simply mean that my string Y is empty. So I don't want my string Y to be empty. So the final answer is the result, that is multiplication of number of times each character appears in string A, multi and -1. Is it clear? Is it clear? Yes, no. Okay, let me show you the implementation. So here I've taken n and s as input. Then I'm counting how many times each character appears in string S. Then initially my answer is 1, and I like, this is the modular value. Then for each element, I'm just multiplying my answer with e plus 1. Why? Because either I can take it 0 time, 1 time, 2 time, 3 time, and all the way up till the number of times it's occurring. Finally, I need to print answer -1. Okay, how many people like have like no doubt in this, and how many want me to explain this again with an example? Like, if okay, I'll take an example. See, let's say we have the string, the strings that are like, let's consider A, B, A only. So how many times A occurs in this? 2 times. And how many times B occurs in this? So in this, A occurs 2 times, B occurs one time. So I can either choose A 0 time, 1 time, or 2 time. I can either choose B 0 time or 1 time. So here I have 3 options and here I have 2 options. Let's say I chose to choose A, maybe let's say once, and B once. If I have taken these 2 options, then my string is decided. I have string Y as AB. I cannot write it as BA because I need to make it lexicographically smallest. So there are only these many strings, 3 into 2. Now I need to subtract 1 from this Y because there is one option which is 0, 0. This means my string Y is empty, right? Like it is not having anything. So that's why number of options, like number of times each character appears, multiplied -1. Is it clear? So I have already shown the implementation for this, right? Just count the number of, like count how many times each character appears. And in your answer, you can multiply it with e+1. Why e+1? Because we are also considering the case when we are choosing this number, this character 0 times. So going to the next problem. So in this, we are given an array A of size n, and we need to construct an array B of size n such that every element of B is present at least once in A. And for every I from 1 to n, every element in prefix of A1 to AI is present at least once in prefix of B1 to BI. If multiple such arrays B exist, we have to find the lexicographically smallest B, lexicographically largest B. So what is lexicographically largest? If 2 arrays X and Y are there and each is of size n. Now the where ith is the smallest index at which they differ, then array X is said to be lexicographically larger than array Y if Xi is more than Y. So let me explain this. So we are given an array A of size n, and we need to make another array B of size n. This is also of size n, such that every element that occurs in prefix of AI, for every AI, in every prefix, like if let's say in this part values 1, 2, and 4 are occurring, so in this part there should be values 1, 2, and 4. Okay, and we need to make B as lexicographically largest as possible. And there is also one more constraint, that if some value X is appearing here, it should be present in A also. It shouldn't be like, okay, because why is this valid? Because, like, why is this needed? Let's say your array was A was 2, 2, 2, 2, 2. So you could have made, if this condition was not there, that if there is X here, here you should also have X. If this condition was not here, you could have simply added 2 here. And after this point, in every prefix, you will get all the elements that are in A, right? So there is no limit what you can put here. Like if you want lexicographically largest, you could put right 10 to the power 10 to the power. Like there is, you can put infinity here. But in the problem, it's given that you can only place elements which are in array A. So tell me one thing. If here is a 2, and let's say there's a 10 here, 2 here, what should be the element that you should put here? Should you put a 2 here or a 10 here? What should come here? If you want lexicographically largest and you want every prefix should have, like in A, element should be there. Why? Because if you put 10 here, it would be lexicographically larger, and already there is a 2 here. So 2 is already there in prefix. So how to solve this problem? The solution is very simple. Just see, let's say you have 3. Let's say this is the array. So is 3 occurring before this? No, it is not. So you have to write 3 here. Is 2 occurring before this? No, it is not. So you have to write 2 here. Is 1 occurring? Let's say there is a 2 here only. Is 2 occurring before this? Yes, it is. So you can, what should be here? Will someone tell me what should be here? We need lexicographic larger. It would be the largest element. So you can write 7 here. Is 5 occurring before this? No, it is not. So 5. Is 5 occurring before this? Yes, it is. So we can write 7 here. Is 7 occurring before this? Yes, it is. And it is maximum also. So write 7. Is 3 occurring before this? Yes. So 7 and 7. So you just need to check if this element occurred before. You can replace it with maximum. Otherwise, write it down. Because if you don't have, let's say you decided you won't write 7 here. So if you don't have, like if you decided it, like you won't have 5 here. So if there is anything other than 5 in this prefix, there is no 5 in B, but there is a 5 in A. So hopefully this is clear, right? Is it clear to everyone? Okay, so let me show you the solution. So this is the implementation. First, I have taken n as input, then I've created two vectors, one of size n, that is for taking input, and another one is empty. Then this is how many, like this is just a map. You don't need a map. You can do it like without map also. But uh, for counting purpose, like how many times each element appears, I have declared this count, and mmmax will have the maximum element that is present in array A. Then after iterating over the elements, if this element is already present, count of E will be more than 0. So just insert max, otherwise insert E. And for each element, just keep increasing the count. Finally, we can print array B. Is it clear? Okay, so let's go to the next problem. So in the next problem, we are given an integer n, and we need to find three positive integers a, b, c, such that n is equals to LCM of AB plus LCM of BC plus LCM of CA. And if there is no such solution, we need to print -1. And if there are multiple solutions, we can print like any of those. So we are given an n. So first of all, let's try to see when does a solution exist and when it does not. So like how I've found this, like I just used a brute force implementation, and I tried to print like for every integer from 1 to n, like 1 to 100, I printed like I used brute force on ABC, and I tried to find if there is a valid pair for which LCM of, like is there a valid triplet for which LCM of AB plus LCM of BC plus LCM of CA is equals to n. And using this only, I was able to see one thing, that it is always possible, not just like it is always possible, expect like expect those cases when n is a power of 2. 2 to the power k. Now, why is this not true? Let me explain. Like you can also like do this, but what is the proof? Like maybe it will be at some point, but why is this not true? See, I have AB and C, right? So let's say GCD of these is not GCD. LCM of these is, what is it? What, like LCM of those can be what? Like I eventually I want LCM of those to be equals to n, right? Because I'm considering there are three integers a, b, c, for which like LCM is equals to that. Instead of like, okay, instead of LCM, let's start with GCD only. And GCD of ABC, let's say this is some simple G. So let's consider GCD of AB as some G alpha, GCD of BC as G beta, GCD of CA as G gamma. if you take GCD of these complete thing, you'll get GCD of A, B, C, and that will be equals to G only, right? Now, from here, I can write, like, let's say A is, what should A be? It is having like factors G, alpha, and it is also having gamma. So G, alpha, gamma. What is B? G, beta, alpha. Alpha, beta, let's write it like this. And what is C? G, beta, gamma, right? And is it like, up till this point, is it clear to everyone? Like, I'm just trying to break them. And here I can write as some, like, there are some other factors also, delta 1, delta 2, delta 3. These will be different only. Otherwise, if these are not different, you'll get different GCDs here. So now if you take GCD, like, this is just a fancy way of writing numbers. Like, don't get confused. If you take GCD of these two, you'll get this thing, exactly this thing, because this is common, G alpha, G alpha. And if you take GCD of all of these, you will get GCD as G, because only G is common in all of these, right? Is this thing clear till this point?
Yes.
Okay. Now, if we let's try to find LCM of these three things, G alpha, G, these things. Okay. What would be the LCM? How can we write LCM? What is LCM? Lowest common multiple, right? So LCM of A, B, and C. What is lowest common multiple of A, B, and C? It is G times alpha, beta, gamma. All these factors will come once. Like, I'm writing LCM of AB plus LCM of BC plus LCM of AB, BC, and CA, right? So let me write it in two steps instead of writing it in one step. So LCM of what is AB is LCM. It is G alpha, beta, gamma, delta 1 into delta 2. These are unique factors that are present in AB. They all will come in LCM. What is LCM of BC? G alpha, beta, gamma, delta 2, delta 3. What is LCM of CA? G alpha, beta, gamma, delta 1, delta 3. I can write this as, this whole term as G alpha, beta, gamma, delta 1, delta 2, plus delta 2, delta 3, plus delta 1, delta 3. Right? So this is the LCM of A, B, B, C, C, A generally. I have not taken any assumptions up till so far. Now, eventually, I want this equals to N. Right? The thing is, if N is something like 2 to the power K, first of all, the thing is, all these numbers, delta 1, delta 1, delta 2, delta, like, at least two of these will be odd. Why? If two of these are not odd, what will happen? If, let's say, two of these are not, like, at least two are even, let's say this is 6 and this is 4, delta 2 is 6 and delta 3 is 4, then you have wrongfully written this thing, GCD of BC. Why? You can multiply this with further with 2. If this is 6 and this is 4, you have written GCD wrong here. But if GCD of these are correct, then this would mean that only at max one of these is even, two will be odd, because the GCD will be 1. For delta 1, delta 2 also, delta 2, delta 3 also, delta 1, delta 3 also, GCD will be 1. So if only one of these is even and everything other is odd, what should be the complete, like, what is the result of this thing? Like, at max, one of delta 1, delta 2, and delta 3. At max, one of these, at max, one of these, only one of these is even. So that means at least two of these is odd. So what is odd times odd? What is odd multiplied by odd? Odd into odd is always odd. So this complete thing will be odd. This complete thing will be odd, right? So you have odd multiplied with something. So odd multiplied with something can never be equals to 2 to the power k. So that's why you can never get an n which is something like 2 to the power k. Is it making sense? Yes, no?
Yes.
Okay. So now one thing is clear, that for every 2 to the power k, the answer will be -1. What about others? Now, for others, the solution is very simple. You can either break it in 3 parts or you can break it in 2 parts. Like 3 parts, you can first of all always, if n is divisible by 3, we can always answer n by 3, n by 3, n by 3. GCD of these two is n by 3, these two is n by 3, these two is like LCM of these two is n by 3, these two is n by 3, and these two is also n by 3. But instead of breaking it like this way, it's like we can also have it in just using 2 steps. Let's say n is odd number. N is odd number, like it is not this thing. N is something like 2 to the power 2 into some x plus 1. It is odd. So can I not write this like it is GCD of x and 1, it is 1 and 1. So what is GCD of these two? It is x. What is GCD of these two? It is 1. What is GCD of these two? It is x. So x plus 1 will give me 2x plus 1, which is the required number. So if n can be written down like 2x plus 1, then the answer is this thing, x11. That is for every odd, which is not 2 ki power, 2 to the power k. 1 is 2 to the power k, okay? 2 ki power, 2 to the power 0 is 1. So you cannot write 1 like this. But for every other odd number, the answer is 2x plus 1, like you x11. What about the other case when you have n is even and it is not 2 to the power k? What will you do then? Like just let's say it is odd is something like 7 into, I need to make it even. So let's say 7 into 4, you have 28. So what you can do, you can write it first like 7 into 4. What should be the answer for 7? You can get 7 by writing it as again 2x plus 1. 7 can be written as 2x plus 1, which is 2 into 3 plus 1. So the answer for like if you want n, if n is 7, you can write it as a is 3, 1, b is 1, c is 1. If you take GCD of these values 3, 1, 1, 1, and again 3, 1, and you add them, I'm saying GCD again and again. I'm sorry, it's LCM. So if you take LCM of 3, 1, 1, 1, and again 3, 1, you'll get 3 plus 3 plus 1, which is 7. Now you just need to multiply this, each of these numbers with 4. And eventually your complete LCM, like all of those LCM of AB, LCM of BC, and LCM of CA will be multiplied with 4, and your complete result will be multiplied with 4. So you'll get answer as n as 7 into 4. So in case of even, if it is not a power of 2, just break your number into 2 parts. With first is like how many factors of 2, like complete power of 2, and another thing is left is some odd number. That odd number can be written like this, 2x plus 1, and just multiply all of these, which is x11, with whatever 2 to the factor you have, 2 factor you have in your n. Is it clear? Is it clear? Okay, I'll show you the implementation. So the implementation is this. In this, I first taken n as input, then just calculate if it is like given n is a complete power of n, like a complete power of 2. So this is 2 to the power p minus 1. I'm just calculating what is the power. So if it is, then print -1. Otherwise, if n is odd, print n by 2, 1 and 1. This is x, what I was writing as 2x plus 1. So this is x n by 2. And otherwise, if there is some power of 2, there is a factor of 2, then first calculate it, then multiply, like you'll still get 10 by 2 is the odd thing that is left, right? here after this. This is 2 to the power p, 2 to the power p, 2 to the power p. You don't need to do this differently. You can do this like this also, because if there is nothing left, then temp will be n only. P will be 0. 2 to the power 0 is 1 only. So this thing will also work. So that's why I was saying you can do this in two cases only. First cases, it is 2 to the power, like the number is 2 to the power n, 2 to the power k, and otherwise it is not. Is it clear?
Yeah, bro.
Okay, so that's it. And thanks for joining. Bye bye.